I appreciate everybody coming to the talk. This is going to be Network 201. This is a tour through network security. This is a follow-up from 2019 when I did Network 101, which was networking for security people. We were still at VCU then, so it's been a while. So we'll see how this goes. Oh, and it helps to turn your clicker on. Yay. Are we going to wake up? Maybe. All right, perfect. So what we're going to talk about today, going to do a very quick introduction. We're going to do a speedy recap of 101 because it's been so long. We'll talk about network security. We're going to talk about what's baked in there, what's kind of the defaults, what the table stakes that you should consider. We'll jump into defense in depth. Right, we'll talk about some risks, we'll talk about some use cases, we'll talk and touch on some recent buzzwords. This is great, actually following Dan from VCU. He talked about some of the things that we're going to talk about, so that's awesome. Hopefully we'll have some time for some questions, and then we'll go from there. So, and ultimately what we're talking about here is this is actually a two-factor or a two-piece thing, right? So we're talking about security of the network itself, the infrastructure, and we're also talking about security on the network. So a little bit differentiation there. Apparently that doesn't work, it goes to sleep too fast. So I'm just some dude. I'll just tell you that right now. So currently a senior solution architect at Intervision. What that means is that I talk to people on the phone to convince them to buy things. I'm a pre-sales guy. So I left engineering, I came to the dark side, and I became somewhat of a sales guy. But how I got here is a little bit of a different story. So I had a different, pretty much varied tech career. This all started because I quit a job. I got a job out of high school, fixing PCs at a computer store, those things that used to exist. I know now that they don't exist, but anyway, I worked there a couple of years. I got sick of it one day and I quit. And my plan was to go back to college. And about a week later, I'd interviewed at a hospital. And a week later, they called me and they said, "Hey, we'd like to come and hire you and come work for us." I said, maybe. How much does this pay? And the lady told me, and it was double what I had been making. I said, that sounds like the job for me. So here I am, and it's been a while. So I had more hair then. It wasn't going gray, but I came by this honestly. I've been privileged to speak at RVAsec a couple times. This is actually round 3 for me. I did a talk, now I can't even remember how many years ago, talking about network authentication, about 802.1x. I thought that presentation had a great title. It was Network Authentication, or That's How I Got This Scar. Still a little scarred from that experience, and it's been a decade. So I have a bunch of certifications. I know some folks care, some folks don't care. Ultimately, certifications are a measurement on your ability to take tests, straight up. I wish that wasn't the reality, but they are. In a lot of cases, tests are trivial pursuit. Right? Whether or not that truly gauges people's knowledge, that's probably a discussion for philosophers and psychiatrists and educational experts, of which I am none of those things, but I'm apparently pretty good at taking tests. So here we are. The speaker this morning, our keynote, the gentleman who was talking, Paul, he reminded me I need to bring this up. I use Linux as my daily driver as well on my personal machines. This machine that's presenting is obviously PowerPoint. This is a Windows box. This belongs to my employer. This is not mine. Everything at home is actually some sort of a Unix variant because I hate Windows. And ultimately, I'm going to end with this. The longer and longer I do this, the more I realize that there's things that I don't know. So, talk about networking. 180 seconds. That's 3 minutes for anybody who can't do the math quickly. Well, it may not be that short, but we'll get through this. So networking, what are we talking about? Well, really what we're talking about is some foundational pieces, the OSI model, right? So quickly, how many layers are in the OSI model? Yay! You make me so happy. I interviewed people for a network engineer role now about 2.5 years ago, and I did not have a single candidate until about 5 months in who could tell me that that number was 7. I was sad. So what are they? Physical, data link, network, transport, session, presentation, application. Now what is in those layers? Physical level, bits on a wire, electrical signaling. Next layer up, data link, what's there? Frames. What's a frame? A frame is a combination of bits with a defined start and a defined stop, right? What has that frame got into it at a higher level? That frame is carrying a packet. Packet is a network layer thing, right? What's the most common packet you're going to find out there today in the wild? It's going to be some sort of an IP packet. More than likely it'll be TCP. Why? Because TCP carries HTTP and HTTPS, because the World Wide Web has eaten the world. For better or for worse, that's what's happened. Okay. So thinking about that, again, most common protocol out there today, IP networking. Used to be a bunch of other stuff out there. There was AppleTalk. There was IPX and SPX. There was Token Ring. All these other various data link paradigms, they've all, I would say, thankfully left us, and we are in an Ethernet world, which is great. Sometimes it can be a little bit of a challenge. Keep in mind there are a handful of other protocol types out there that still exist at layer 2, right? Most common ones that you're going to see and that you should be aware of from a security perspective, 802.1q, that's VLAN trunks. 802.1ab, that's LLDP, link layer discovery protocol, right? Neighboring protocol for network gear. All these kind of fun things you can see in a packet capture, right? So if you get your network team to give you a span port, monitor port, depending upon who made the gear, that's what they call it. You set up Wireshark, OmniPeak, anything like that that captures packets. This is what you're going to see potentially coming out of that network on the wire. You might also see 802.1x, which is port-based access control. So something else in there. Now, as we're talking about IP networking and Ethernet, there is a limitation that we do run into from a security perspective, because in many cases we are working to secure communications, right? We're securing packets that are transported from one place to another. Well, great. How are we doing that? Well, we're actually doing that by encapsulation. We're taking the thing, the original data, and we're putting it into another container, right? Well, we're adding really what basically becomes additional mass, right? So we take the container, if you take 5 gallons of water, you pour it in a container, it weighs what 5 gallons of water weighs plus what the container weighs. In comparison to water, the container probably doesn't weigh much. In this case, when we talk about encapsulation, it doesn't weigh much. However, it weighs something. It has some sort of length. And what we're dealing with here is that the largest Ethernet frame can carry 1,518 bytes, right? That's as big of a frame can be. So if you have a higher level protocol, let's say it's going to be UDP, we're going to encapsulate. It becomes encapsulated with IPsec. And all of a sudden, we're bigger than that. That means it's got to be fragmented on the wire. It's okay. That could run us into problems, right? If you've ever heard of something called an MTU, a maximum transmission unit. So if you've ever had a VPN connection that doesn't seem to work right, it's like, nah, this doesn't seem to function, or it's really slow. Just like, man, this is annoying. That wouldn't be surprising you're running into an MTU issue. So something to keep in mind. This is becoming more and more common because ultimately, from a circuiting perspective, from a true physical connectivity perspective, there are more and more Ethernet circuits out than there used to be, which is awesome because Ethernet's a lot easier to deal with than what I would call a TDM circuit, time division multiplex circuit, which is things like T1s, T3s, OC3s, OC12s. Those are all based upon ultimately having multiple streams that get interleaved together onto the wire. So thankfully, we've kind of gone away from that. Various TDM schemes have had different maximum frame sizes. On occasion, it can cause strange issues. Thankfully, I would say we're mostly by that by now, which is good. So we talked about encapsulation. We've talked about some of the pieces we can see in IP networking. Let's not forget the most common 3 protocols that we're going to see out there. These are transport protocols, all right? Things that carry applications for us. So ICMP, TCP, UDP. So ICMP, ping. Ping and ping reply are the most common things you see. Yeah, there's a bunch of other stuff in ICMP. In a lot of cases, it's not used or it's filtered out because someone thinks it's more security. Apparently, they've totally forgot about that whole I and that A part of the CIA triad, the integrity and the availability portions, but okay. TCP, connection-oriented. This is another question that I've had multiple candidates fail on me. What's the TCP three-way handshake? You guys are qualified for a job. No kidding, it took me 5 months to get someone to answer that automatically. I had a guy struggle through it. I had a guy told me that the FIN flag was sent to set up a connection. Never been told that one before. It was a bad scene. Extra points if you know the correct TCP hang-up sequence. It's extra points anyway. It's fine. So it's ACK FIN, ACK, ACK FIN, ACK. I say 4 ways. It's really 2 ways, but those are what you're going to see when you actually hang up a connection. Now, in a lot of cases, that doesn't happen because applications just let things time out. But that is the graceful way to shut down a TCP session. UDP, connectionless, again. You know, if I told you a joke and I didn't care if you got it, what would that be? That would be UDP. Now, we talked about here about transport protocols, things that carry things for us. So what actually is being transported? And those are the common protocols we're used to, right? HTTP, HTTPS, FTP, DNS, CFS, SMB, NTP, SSH, Telnet. That's all things that are carried across here. Some other protocols that you're going to probably see and are important to you as a security professional. GRE, generic routing encapsulation. ESP and AH. AH is authenticated header, and ESP is, I'm glad you saved me because I totally blanked on that. Another one you're going to see, IPsec, IP security. A couple other things that we want to talk about here. And kind of going with our theme of transport and transported protocols, we have routing and routed protocols, right? So a routing protocol is something that the network uses itself to exchange routing path information. So routing protocols, OSPF, open shortest path first, BGP, border gateway protocol, EIGRP, enhanced interior gateway protocol. That's Cisco proprietary, but for better or for worse, Cisco has an awful lot of networking market. You're going to see it. RIP, routing information protocol, ISIS, intermediate system. That's a service provider thing. I don't see it much in customer networks, but it is out there, right? And then routed protocols, this thing we talked about, transported protocols, right? So our friends TCP, our friends UDP, GRE, IPsec, it's kind of stuff that's out there. Last thing in networking, and then we'll move on to the fun stuff, I promise. And this is one of the things that I do run into in networks, doing assessments for customers, because ultimately networks are something that are grown organically, right? And they are grown to fit the business, fit the needs, which is awesome. The challenge comes in where they're grown without a comprehensive plan, or they're not built consistently, which is why I'm talking about we want to design and implement appropriate network architectures, sustainable architectures, resilient architectures, robust architectures, right? If one network component goes down, the entire network can no longer transport packets, that's a failure. That's not what we want to aim for. Again, step back, think about that CIA triad: confidentiality, integrity, availability. If the network is down, we have failed availability. And the last thing I'm going to say about this architecture-wise, just because you can doesn't mean you should. And that's for all the people out there when I come behind them and I find out that they've done silly things like 3 different routing protocols in a network with 4 circuits. For the love of God, don't do stuff like that. Just because you read it in your CCNA or your CCNP or your CCIE book, don't do that. So, you're here and you just heard Dan Hahn talk about all the lovely things you can do with Zero Trust. He talked about SASE. So, you know, hey, everything is a browser now. Isn't network security old and busted? Nobody cares anymore. You know, we don't need that stuff. Everything's in the cloud. There's unicorns, there are rainbows, there's manna coming down from the heavens, there's security guys spending their commissions on boats. It's awesome. No. What's interesting this morning, listening to the keynote, and the presenter brought up the fact that he's like, I'm putting these slides together, and here's a slide from a presentation I gave at DerbyCon like 10 years ago of my top 10 things I was concerned about then. And he's like, I'm looking at the slide now, like last week, putting my slides together. It's the same 10 things, right? And we continue to fail at the fundamentals. We continue to fail at the foundations. I know it's not cool. I know it's not sexy. I know the vendors upstairs are probably not going to spend a dime on the foundational stuff. But it's important. You can't build the fancy stuff with a broken foundation. It doesn't work. You know, why does the OWASP top 10 still include SQL injection? Everybody knows about SQL injection, right? Still a problem. I'm still running into that. We're still seeing it, right? Just one of those things. It's the same things over and over and over again. So what we want to do is we want to build a strong foundation that enables us to do the cool stuff, the new stuff, the fancy stuff. So let's talk about some basics, some things that we can build from, we can build on. So first thing to do, have a plan. Again, I know this isn't cool. I know people love to hate project managers. I used to be one of those guys. I know everything. I don't need help. Well, I got news for you, kid. Have a plan. If you don't have a plan, you are planning to fail. And I hate to say, using that cliche, but it's reality, right? Plenty of times I come in, talk to folks, look at their environments, all kinds of tools, all over the place, no consistency, no thought of how this ties together. What they've made is a giant science project. It's not any fun. It doesn't help anybody. So if you have a plan, what do you need to know? You need to know what you have. You need to know what your assets are. There's a reason that this is like the first thing in the CIS top 18. It was the same thing in the CIS top 20 before it. You got to know what you have, right? You can't protect what you don't know exists. And you'd be amazed how many people have no idea what they own. Just not a thing. So, because what's happening is we built networks to communicate, to allow and to enable communication. That's awesome. People just plug stuff in, it magically works. That's awesome. And then one day it doesn't work and they ask, hey, this thing is broken, can you help? And you go, what are you talking about? So, again, figure out what you got. Consider your risks. If the system isn't worth protecting, don't spend time and resources on it. If you have old data, maybe get rid of it. Do you need all that stuff? You know, do you need WordPerfect templates for the DOS version? I know that dates me, I don't care. Do you need that stuff? Is it workable? If you don't need it, get rid of it. Again, defining your assets, defining the importance, defining the criticality helps you really hone in on what's important and what we are working towards and how we're going to manage our risk, right? We're not going to eliminate risk. I know there's a vendor upstairs who has a furry four-legged animal as their logo, and they say, end cyber risk, which I know sounds great to a marketing person. That's impossible. I wish it wasn't, but it's impossible. So I always chuckle every time I see that. As we're considering risk, we're also thinking about, hey, is this going to be, how hard is this going to be to recover? If it's something that's super easy to recover, maybe I don't worry about protecting it as much. However, if it's a super complex system that would take me 3 weeks to rebuild, maybe I should put an awful lot more focus on protecting that system. Something to consider. Also, inside this point of discussion, think about any sort of cloud environment you have. Be aware of that shared responsibility model. If I had $1 every time somebody told me, hey, I moved to Azure, I'm done. This is Microsoft's problem. I wouldn't be standing here. I'd be on a beach. It's not Microsoft's problem. The shared responsibility model is real, and it can be a rude awakening for folks, especially executives, when they see it. It's like, oh, Microsoft doesn't back any of this stuff up. They don't actually care about my data. They don't care. They're potentially holding it for you, but if one day it doesn't work anymore, it doesn't exist, they're going to shut their stores and go, hey, we're really sorry, your bill's due in 3 more days. Please pay. So, also talking about risks, talking about importance, what systems are important to who, engage with the business owners. IT is not the business owner of a system in all but very rare cases. Let me just put that little asterisk there on the end. But if it's a line of business system, if it's an ERP system, IT doesn't own that, purchasing probably owns that, right? Accounting probably owns that. If you have a system that tracks payroll, payroll owns that, accounting owns that, finance, not IT. IT is the custodian of that information. They're not the owner, right? Talk to those folks. I'm always amazed when I go and I talk and I engage with customers and I engage with business leaders and not the IT group. Because what they tell me is generally way different than what the IT folks are telling me, right? Did an engagement for a small health system out in the Shenandoah Valley, and the IT guys are telling me, hey, you know, I need a way to make sure that my doctor's offices stay up, and if they lose their WAN circuits, that they still need to be able to make phone calls and need to figure out how they can fail over and still use their ambulatory care application. Super important. We need to do this. Okay, great. Hey, there's some other pieces and parts we're concerned about. Oh yeah, let's get us all in the room and talk about it. And the first thing that the ambulatory folks, the folks who run these doctor's offices, said to us is they said, hey, you know, if the network goes down and we can't work, we're going to just close the office and either send folks home or send them to a different office. We're not worried about it. Like, oh, okay, well then let's talk about something else then. Secure your infrastructure. This is things like changing the default password. I can't believe I'm still saying this, but I'm still saying this. And the thing that galls me about this the most is hardening the infrastructure, securing the infrastructure is almost always free. It doesn't cost any money, it just costs some effort. I mean, legitimately, if you can do a Google search on your manufacturer's hardening recommendations and read the web page that I guarantee you is probably a decade older, you can go a long way to do this. But just, it doesn't happen, right? So, disable unused services, seems obvious. Remove default credentials, enable logging. If you can go even farther, enforce secure admin access, maybe do some kind of multi-factor on it. Oh, by the way, please use SSH. Don't use Telnet, please. Well, maybe the red team will be okay with you using Telnet. You never know about those folks. If you have a Center for Internet Security, a CIS membership, they publish benchmarks for free, but if you have a membership, they have options. You have the ability to get and access things like scripts that you can pull a config down, run the script against it, and it'll tell you, hey, here are the recommendations to make this a more secure device. If you work for a local state government, or I think also education, you can get a membership for free. So take advantage, right? I mean, you're basically going to get, you're getting the insight from a very large organization across the globe on how to better secure your systems. Like I said, it's there, use it, great stuff. Going along with this, I hope you have logs. If they're immutable, it's even better. If someone can get to your log server and run, rm-rf and /, that's not so good, but please at least have them. That's something. Ultimately, with your tooling, tools are awesome. Tools are what makes sales guys have commissions. That's great. Tooling is not fire and forget. It's not. It requires engagement. It requires tuning. It requires attention. I've had a couple of customers bought all the things. I mean, legitimately, every tool you could potentially think of, possibly think of under the sun, they had it. Had everything. They had great EDR. They had next-gen firewalls. They had network segmentation. They had all this stuff. What they didn't have was anybody binding the store. An attacker got in, got a footprint, and basically destroyed their environment in the matter of about 12 hours or so, as we can figure. And to add insult to injury, you could go into the EDR tool, and you could see the infection happen, and you could see what the guy did. It was all there. No one was watching. So, last thing I'm going to say, if it's in the cloud, it's still your problem, right? Your problems are actually just beginning. So, defense in depth, network security, let's go. So we need some foundational pieces, right? Can't just build a building without putting the foundation in. Got to put the concrete in the ground. So, start from the data. What do you actually care about? You care about the data. I don't care about a computer. These things are disposable, straight up. They are. When they get too old, we throw them away, right? It's what's in this device that matters to me. It's the data that matters to us. So, know the data, know the applications. This gives you an opportunity to engage with your business owner, right? Again, you're the custodian. You take care of this thing. You don't own this thing. So think about having a way to track and figure out who actually owns this. Is this, Sam in accounting? Is this Mary in HR? Who owns this thing? Because if you can identify the owner, they can also help you determine who's supposed to have access to this. That becomes important later on. This also gives you a chance to figure out what this data is, like what it's used for. Sometimes the risk of stored data is obvious. Hey, I've got a database that's filled with people's name and birth date and social security number and their credit score, and obviously you want to protect that stuff, right? And that's obvious. Hey, that's something that's pretty much confidential. We need to keep that. We wouldn't publish it on the internet. Okay, cool. Sometimes it's not so obvious. Talked to a billing company. They're a company that you call up and you pay your bill, and you can talk to a rep, a live rep, to do that. The system that the reps used to charge the credit cards with was PCI compliant. As soon as the rep typed the number in and hit the button, the number disappeared. They couldn't see it. They couldn't see any details. All they would get back was, hey, this charge succeeded. That's cool. You're in great shape. Hey, Do you record the phone calls for quality assurance purposes? Well, of course we do. So when the customer reads their credit card number off, that gets recorded too, right? Well, yeah, I guess so. Where are those recordings stored? Not in this PCI compliant system. They're stored on an open file share. Whoops. Thankfully, that's one of those ones we found before somebody else found, right? So if what I'm saying starts to sound like parts of the cybersecurity framework from NIST, you're getting a gold star, because I'm basically telling you the identity phase. All right, I will not bore you with reading the identity phase, but basically it says understand the business context, the risk, so on and so forth, right? One other thing to kind of think of here, like I said, we talked about business owner, considering the risks. Policy, procedure, guidelines, and standards definitely have this stuff. It's good. Great opportunity to ask, what's the relationship between the security team and the networking team? If you're the same people, that's easy. You probably like yourself okay. Cool. If it's somebody different, start building the relationship, right? Because in many cases, what I find out is the security organization wants certain things, the network organizations want different things, and you have to, obviously, ultimately, you have to come to a meeting of the minds here, right? You need to work together, you need to collaborate, because ultimately, you both want in an organization that continues to function and functions securely. No one wants to show up at the office one morning and find the doors chained shut with the lights off. That's not any fun. But there's certainly a risk that that can happen. I had a customer, small business here in town, got a ransomware event. The attacker literally destroyed everything, Active Directory, every file server they owned, Exchange, I mean, basically totally non-functional. On a call, CEO, CFO, IT director, and us as well as the IR firm. And the CEO said that if they had gotten the ERP system, that they would just close. And the only reason that their ERP system survived is that it ran on HP UX. On hardware that's probably, well, certainly the hardware is older than my oldest, who is going to be a junior in high school. So the reason it survived is that it only answers to Telnet, and the attacker never scanned for that because he figured that stuff just wasn't a thing anymore. So basically, they lived because of pure dumb luck. Okay, I'll just tell you, hope is generally not a survivable, consistent strategy, but it worked for them this one time. So we touched on this, data lifecycle. If you don't need it anymore, throw it away. Delete it. Don't need it. Actually had a customer that saved themselves all kinds of money spent on lawyers because they continued to get discovery requests from opposing legal counsel for basically their business history. So the customer used the tool, went in, found a bunch of data that was ancient, nobody had touched in literal decades. They deleted it all, and then the next time they got a discovery request from part of a lawsuit, they could say, hey, don't have that stuff anymore, it's all gone. So save themselves all kinds of time and hassle and effort. So that's great. Okay, a little more concrete pieces here. We're still inside the cybersecurity framework. We're out of identity, we're into protect. The obvious stuff, again, I mean, this is all super obvious. Access controls, right? User onboarding, somebody gets hired, cool, they need access. Somebody has quit, they retired, they won the lottery, whatever it is. User offboard, don't need access anymore. Only give them access to what they need. They shouldn't get access to everything, right? You wouldn't say, oh, hey, you're a new marketing rep, that's awesome, here's your domain admin creds. You wouldn't do that, right? Same sort of thought across all the systems. Somebody from marketing doesn't need access to payroll, right? If you can do multi-factor authentication and single sign-on, do it, absolutely. Think about network access control, that's NAC up there. Of course, test your stuff, right? Pen tests, that's the sexy red team stuff. Disaster recovery tasks, maybe that's tabletop exercises. Again, things that you can do here. Something else in protect, right? Reduce your footprint, harden servers. We've talked about all this stuff, but I keep saying it because I keep finding people who don't do it. It drives me up the wall. Though I guess it's okay because it keeps me employed. So that's something, right? Detect. You want to be able to detect what's going on there. Do you have EDR? Do you have MDR, XDR, whatever the great acronym is right now? Got instrumentation on your network, right? You're looking at net flow. You're looking at utilization. Looking at logs. You're actually looking at the logs, not just collecting them for grins, right? Something else that plays in here is thinking about, do you have an SLA with a vendor on a particular application or a particular service? Can you detect if they're violating the SLA so you can get credit, right? When I worked for a large health system, we spent, no kidding, our bill for networking, for WAN networking, was 6 figures a month. That's a lot of money. Now, in that contract, we had SLAs where they would guarantee downtime, they would guarantee packet delivery, they would guarantee time to repair. And if they missed those SLAs, we got credits. We had one particularly bad month for us and for them that we did not pay the bill because they owed us money back. But like I said, got to put that in the contract. Going to respond, right? If it all goes sideways, and it probably will, have a plan, execute, adjust if necessary, right? Having a plan is good, super important. Testing the plan, even better. But don't be so wedded to the plan that you're not doing an effective job in responding, right? When the building's afire, it's not time to debate what kind of hose to use to put the water on the fire, right? So, recover, right? The obvious stuff. Got your backups, right? Maybe you have to rebuild something. That's okay. Might give you an opportunity to say, hey, the server got messed up and it was Windows Server 2012 R2. Maybe I'll build it on Server 2019 instead. Make it a little easier from a lifecycle perspective. That works. Also, take the opportunity to figure out how this went wrong. Do lessons learned, right? This is a great opportunity. I mean, testing is awesome. Tabletops are great. Nothing teaches like the real thing, right? Don't let that opportunity pass you by. I know sometimes incidents are a opportunity for punishment. Shouldn't be. Doesn't matter how smart you are, how much money you have to spend. You have to be right 1,000,000 times every time. The attacker has an advantage. He has to be right once, and he or she can get you good. So, like I said, always consider those lessons learned. All right, so self-hosted applications. What do I mean? I mean stuff in your data center. I mean stuff in infrastructure as a service, right? So if you have stuff in Azure, you have stuff in AWS, doesn't matter. We're still talking about the exact same thing. Just because it happens to be on someone else's computer, it's still you, it's still your problem. Oh, same thing with containers, by the way. Containers are basically a service running on someone else's VM. I thought they were cooler when they were called CH root jails, but that probably dates me again. That's okay. Segmentation. Again, this is an extension of our least privilege, need to know principles, right? Can be as easy as a couple of VLANs and different subnets with some static ACLs between them. Great. Could be microsegmentation with something really cool like VMware NSX. All right, great. We want to inspect content. Is someone trying to exploit my servers? Intrusion detection, intrusion prevention, right? Something's going on. I want to be able to have visibility, be able to be alerted, take action, right? Now, there's an awful lot of encrypted traffic in the world. Think about how I could potentially get into encrypted traffic, get that visibility, Depending upon the traffic and the protocol, different ways to do it. So just kind of keep that in mind. Web apps. The World Wide Web has eaten the world. That's cool. Makes everything available versus a browser. Really saves us from installing a bunch of software on PCs. That's kind of neat. Downside is the standard firewalls, intrusion detection doesn't do a great job of protecting web apps, which is why there's a special thing called a WAF, Web Application Firewall. So if you have a web server that faces the internet for public use, think about this. Even if you have one for employee use, also have this. Just because it's an employee on a corporate asset doesn't mean that they're going to not be used as a pivot point for an attack. Of course, you're going to want to patch your stuff, and you're also going to want to potentially filter your outbound user traffic, right? Because if I have data, I've got stuff I need to protect, and I have a user who takes it and copies it somewhere, well, I've lost it, right? I need to make sure I have that. So also, having sanctioned and unsanctioned applications. If your standard is, hey, we are an Office 365 shop, we use OneDrive here. Cool. So why is someone using Dropbox, right? They're copy and paste. I mean, it's awesome. It makes it so much easier to work. You can work from anywhere. The downside is that people can copy stuff kind of however and wherever they want. Maybe not exactly what you want, right? If you are in a public cloud, think about potentially a Cloud Security Posture Management tool, CSPM, right? This is a way for you to figure out, hey, somebody has enabled a network security group that allows RDP direct to a VM from the internet. Probably not a good thing, right? So let's pivot a little bit. Let's talk about SaaS apps. Even more so in SaaS apps do people tell me, hey, it's the vendor's problem. Well, it's probably not. I would encourage you to read your contract. You'll probably figure out that they say, hey, you put data in here, we'll do reasonable efforts or commercially reasonable efforts or some other sort of kind of weasel words that will ultimately say, hey, if we lose your stuff, we're sorry. And you can't sue us, by the way. So know that shared responsibility model, know those SLAs, hold your vendor's feet to the fire, right? Thinking about SaaS apps, what people are using them to do, what data might be interchanged. This is a place where a cloud access security broker, a CASB, might help you out, right? Gives you a chance to potentially have visibility and control what people are putting in there. You can say, hey, if someone tries to type in a credit card number into a free text field, I'm going to disallow that. I don't want that to happen. Okay, great. Now, what you can sometimes find is CASBs will be baked into things like SASE, Secure Access Service Edge, or ZTNA, Zero Trust Network Access. So, like I said, something to consider here. There might be a component, might be separate. Yeah, really depends upon your organization and kind of what your mix of applications and controls are. We touched on sanctioned and non-sanctioned applications, right? And again, that might be a place where a secure web gateway comes in and prevents people from going to, like Dropbox as an example. So, a bunch of different ways to make this work. What we're talking about is what makes sense in your environment is going to be driven by where your users are, where your applications are, which means where is your data, right? So talking about these buzzwords of SASE, ZTNA, right? Everyone's like, this is so cool. You don't need firewalls anymore, and you don't need this, and you don't need that, and blah, blah, blah. Well, maybe, right? Sometimes I think there's more hype than actual technology produced in the industry. But here we go. I'm going to jump into Secure Access Service Edge. First thing I'm going to hit you with, a definition in general. A cloud-based security framework that combines networking and security functions together. It doesn't sound all that unique, but maybe it is. So way to think about this is a combination of always on VPN, firewall as a service, and maybe a secure web gateway, right? Those three things are not new. What's new is packaging them into one nice marketing term. So does this make sense for you? It might. Where are your users? If they're all in the office, this probably doesn't make a heck of a lot of sense. Where are your applications? If they're in your own data center, this may not make a whole lot of sense. So know the use cases. In a lot of cases, SASE is a building block for ZTNA, Zero Trust Network Access. Now, I know we just saw a wonderful presentation talking about zero trust, and I know his definition doesn't match mine. However, when you search Zero Trust Network Access, this is what you get from Google. Don't come at me about it. I just report, right? So, a lot of different pieces about zero trust, this and other thing. If you think about that, you read the definition, you go, man, that sounds like VPN. And it kind of is VPN, honestly. This is, again, an evolution. This is not a revolution. Really what we're talking about is we've got a slightly smarter VPN client that can dynamically steer traffic and also enforce policy for you from a central control point. That's really what we're talking about. So, again, not revolutionary, evolutionary. Now, what you can do with this is you can indeed get a segmented environment together over an environment that already exists with an awful lot of stuff, right? That's cool, because sometimes rebuilding an environment is way more than it's achievable. That's a positive thing. It takes time. This is not a 5-minute engagement at all, right? Be prepared to spend a couple years doing this. So, doesn't sound as awesome as I thought. That's okay, right? So, is this applicable to you? All right, well, think about where your organization is going. Are we on-prem? Are we remote? Are we hybrid? Are our applications SaaS? Are they data center? Are they somewhere else? Again, let's think about where we're going, right? You know, are we remote forever? Hey, we've given up the offices. Everyone work remotely. We'll see you on Zoom. All right, cool. Or maybe you're working for a place that's like, nah, we're done, it's over. Kind of come back. We want to see you in the office again. Okay, I mean, it's a thing. Or maybe it's, well, we're going to just be hybrid because we don't want to poke this bear too hard. All right, it's fine, right? The nice thing is these solutions can adapt to these use cases. And maybe the adaptability is we don't need that thing, right? So keep your mind open, think about it. Always have your BS meter engaged, right? And with the data. It's all about the data. So very quickly, recap. I know I'm holding you up from an adult libation. I'm sorry. Network security, still here, still a thing, still important. Not going to go away anytime soon, no matter what somebody says in a marketing slide, right? Think about it. Plan. Plan, plan, plan. If you shoot from the hip, you're going to cost yourself money. You're going to get frustrated. Avoid that. That's failure, right? Secure the infrastructure. This is easy. This is free. Takes some effort. It's all good. Secure the data. This probably goes without saying, but that's actually what we're aiming to do here. We'll try this. Secure the users. This is actually hard. At the end of the day, people are what make this so rewarding and also so frustrating at the same time. And I am honestly not sure where the next generation is going to do this because my kids, I cannot get them to even not tell the other their passwords. It drives me up the wall, considering what I do for a living, but we'll see how it goes. I have got the sign, so don't rest on your laurels. Questions? Oh, this is easy. All right, awesome. Thank you.